Mastering SOC 2 for AI companies. Everything is in, nothing is out, in our pursuit of operational perfection. When defining the scope of our SOC 2 audit, what specific systems, processes, and assets will be included, and which ones will be excluded, to ensure that our company's operational excellence is accurately reflected in the audit's findings? As I sat in the boardroom, surrounded by my team of experts, I couldn't help but feel a sense of unease. We were about to embark on a journey to achieve operational excellence through a SOC 2 audit, and I knew it wouldn't be easy. The stakes were high, and the margin for error was slim. Our company had built a reputation on innovation, pushing the boundaries of what was possible with AI. But with great power comes great responsibility. We had to ensure that our systems, processes, and assets were not only cutting edge, but also secure, reliable, and trustworthy. The question on the table was deceptively simple: what to include and what to exclude in the scope of our SOC 2 audit. The answer, however, was anything but straightforward. We started by considering our most critical assets, our AI algorithms, customer data, and intellectual property. These were the crown jewels of our company, and any breach or compromise would be catastrophic. We knew we had to include these in the scope of the audit, but where did we draw the line? As we delved deeper, we realized that our entire architecture was interconnected, a complex web of systems and processes that relied on each other to function. Excluding certain components would be like trying to remove a piece of a puzzle. It would compromise the entire picture. I remembered a conversation I had with a fellow CEO who had undergone a similar audit a year prior. He had told me about the importance of understanding the context and nuances of each system, and how a small oversight could have far-reaching consequences. His words echoed in my mind as we debated the scope of our audit. We decided to take a holistic approach, considering not only our technical infrastructure, but also our governance, risk management, and incident response procedures. This would give us a comprehensive view of our operational excellence, warts and all. But as we expanded the scope, I couldn't shake off the feeling that we were biting off more than we could chew. The more we included, the more complex and daunting the task became. I thought about the potential risks, the potential costs, and the potential reputation damage if we failed. And yet, as I looked around the room, I knew we were all on the same page. We were committed to transparency, to accountability, and to excellence. We were willing to take the harder road, even if it meant delayed timelines and increased costs. The days turned into weeks, and the weeks turned into months. Our team worked tirelessly, gathering evidence, documenting processes, and implementing controls. It was a grueling process, but with each milestone, we gained clarity and confidence. Finally, the day of the audit arrived. Our assessors pored over our documents, interviewed our teams, and tested our systems. It was a nerve-wracking experience, but we were prepared. The results were in, and we had passed with flying colors. Our operational excellence had been validated, and our company's reputation had been enhanced. As I looked around the room, I felt a sense of pride, relief, and accomplishment. We had taken the road less traveled, and it had paid off. In the end, we had learned a valuable lesson: that operational excellence is not just about checking boxes or meeting compliance requirements. It's about understanding the nuances of your business, the context of your systems, and the implications of your actions. It's about taking the harder road, even when it's easier to take shortcuts. As I left the boardroom that day, I knew that our journey to operational excellence was far from over. But I was confident that we had laid the foundation for a culture of transparency, accountability, and continuous improvement. And that, to me, was the greatest achievement of all. To ensure operational excellence is accurately reflected in the SOC 2 audit findings, it is essential to carefully define the scope of the audit by identifying the specific systems, processes, and assets that will be included and excluded. Here's a comprehensive approach to scope definition. In scope: systems, processes, and assets. 1. AI model development and training environments include all systems, tools, and infrastructure used for developing, training, and testing AI models, such as data preprocessing, model deployment, and hyperparameter tuning. 2. Data management and storage include databases, data lakes, data warehouses, and other data storage solutions that contain sensitive data used in AI model development, training, and deployment. 3. APIs and microservices include all APIs and microservices that interact with AI models, handle data input/output, or provide interfaces for users, customers, or other systems. 4. Cloud infrastructure and services include cloud-based infrastructure components, such as virtual machines, containers, and serverless functions that support AI workloads. 5. Monitoring and logging tools include systems used for monitoring AI model performance, logging errors and exceptions, and detecting security anomalies. 6. Change management and version control systems include systems used for tracking changes to AI models, code repositories, and version control systems. 7. Access control and identity management systems include systems used for managing user identities, authentication, authorization, and access control for AI systems and data. In scope processes. 1. AI model development and deployment include processes related to AI model development, training, testing, deployment, and maintenance. 2. Data management and handling include processes related to data ingestion, processing, storage, and disposal, as well as data quality control and data loss prevention. 3. Incident response and disaster recovery include processes related to responding to security incidents, maintaining business continuity, and recovering from disasters. 4. Change management and configuration management include processes related to managing changes to AI systems, configurations, and code. 5. User access and role management include processes related to managing user access, roles, and privileges for AI systems and data. Out-of-scope systems, processes, and assets. 1. Non-AI systems exclude systems not directly related to AI model development, deployment, or operation, such as HR systems, marketing automation platforms, or customer relationship management systems. 2. Third-party services exclude third-party services that are not critical to AI operations, such as payment gateways, email marketing tools, or social media management platforms. 3. Personal devices and assets exclude personal devices, such as employee laptops or mobile phones, unless they are used for AI development, testing, or deployment. 4. Non-critical infrastructure exclude infrastructure components not essential to AI operations, such as office printers, Wi-Fi networks, or non-production environments. 5. Legacy systems exclude legacy systems or assets not currently used or integrated with AI systems. Scope definition best practices. 1. Involve stakeholders, engage relevant stakeholders, including AI developers, data scientists, operations teams, and security experts, to ensure comprehensive scope definition. 2. Conduct a thorough risk assessment, identify potential risks and threats to AI operations, and prioritize in scope systems, processes, and assets accordingly. 3. Use a top-down approach. Start with high-level processes and systems, and drill down to specific components and assets to ensure comprehensive coverage. 4. Document and review. Document the scope definition and review it regularly to ensure accuracy, completeness, and relevance. By following this approach, AI companies can ensure that their operational excellence is accurately reflected in the SOC 2 audit findings, providing stakeholders with confidence in their ability to manage and operate AI systems securely and efficiently.